Question 20. So, good question here. Some bits harder than others. So let's get the easier bits out of the way first of all. We've got to show that the total surface area equals something. So let's leave the cone aside for now. This surface area comprises a circular base, this curvy bit of the cylinder, and the cone. So obviously the base is a circle, so that's pi r squared. So pi times the radius squared, pi times 10 squared, which is 100 pi. Now the curved surface, the surface area of the curved cylinder, remember that's basically a rectangle when you fold it out, of which one dimension is 10, but the other dimension when folded out would be the circumference of the circle, which is pi times diameter of 10. So once you've turned this curved piece into a rectangle, it's the circumference times the 10, so 10 times pi times d, which is 20, so that's 200 pi. So far we've got the curved side part of the cylinder and the circular base being 300 pi, 100 pi and 200 pi. Now back to the cylinder. If you look at the formulae, you'll see that the surface area of a cone is pi r L, but L is the diagonal length, the curved length. Okay, so really you just got to take on board that we can work that out by way of Pythagoras. That's a length of 10, that's a length of 10. The hypotenuse we get from saying the hypotenuse squared equals 10 squared plus 10 squared, which is 200. So L, that curved length there, is the square root of 200, which is 10 root 2. So back to the formula, the surface area of a cone comprises pi times the radius times the diagonal length, so pi times 10 root 2, which is 100 pi root 2. So our total surface area comprises the base and the curved cylinder, 300 pi, plus 100 pi root 2, and then just take the pi out to factorize, and that gives us what we had to show.